The Bluetooth low-energy ambient sensors aim to collect your instant environmental information whenever necessary. With our device and software app, you can easily access accurate values of humidity, light intensity, temperature, and pressure around you. Look at this device. These are 3 sensors which collect data, and this is school that deals with all data collected and sends them out to our mobile phone via Bluetooth. This is humidity and temperature sensor. This is RGB light sensor. And this is the altitude and pressure sensor. The breakout board provides several ports to connect all devices together. To set up our device, you just need to plug in the battery. When the LED starts to light, the whole system starts to work.
Our sensors are connected to square ball through I2C. As learned from class, we first send a specific 7-bit device address and 1-bit read and write to SDA to wait for slave to acknowledge. For write transaction, we send a series of data which contains the specific register address on the device and the contents we want to write on that register. For read, we just need to send the address of register that we want to read value from. Specify the data length we need, then wait for slave to acknowledge and send back the data to school. We wrote all the header files and source files for our sensors. Generally, we have a function to initialize the specific sensor and the other function to do the data read transaction from the sensor. Then for this different sensor, we need to write different register value to figure out different test part. Finally, we send a read address to device and receive the data measured by the sensor. The most sensors have the available data length range from 1 byte to 3 byte. We also need to transform the data from the real value which could show for customer.
Our whole system is time interrupt driven. We generate a time interrupt every 0.2 seconds, and during every interrupt, we first record the data from sensor, and then a set of data will be sent to our mobile device by notification with the GATT custom service. Overall, in 6 cycles, all the data will be refreshed and updated in our mobile app.
Now we will have a brief demo of how our system works. First, we click on the Scan button, and it will list all the scroll devices near you. Click on Connect, and your phone will connect to the scroll. What's more, we use connection mode rather than the broadcast mode in our implementation, which means only you can connect to the device, so you have the privacy, you own the device, and the connection mode provides a low energy solution to our project. The system will not work until connected, so the system will automatically suspend when you don't want the data. But when you start the app, the system will be awakened. Now I will show how light sensor work when we cover the sensors. The data here is become smaller. When I remove my hand, the data is become bigger. And then I blow at the humidity sensor. And you can see here, nearly 100. And you can see the plot, which shows the change of the humidity. Here we collect the 10 most recent data of the humidity and doing this plot. And we do the same thing for our temperature.
In conclusion, we first collect environmental data from sensors, and school receives the data via I2C. The received data then is sent out through BLE, and a one-to-one user-friendly mobile app is developed to receive all the information and display the results to our user. There are many things that we can improve for our project. For instance, we can add a function for the mobile app to control the time interrupt interval of school. In this way, we can either record the environmental data every 1 hour to trace the relevant information for a long period of time. Or we can also get the instant data which is updated rapidly.